Now, what I also want to do, example that is a little more complex. So in this example, we have a couple issues. In this one, not only is this not a perfect square, neither is the 2. So in this example, what we're going to want to do first is actually get rid of that 2 first. So we're going to divide everything over here by 2. Over here as well. But 0 divided by 2 is just, oh sorry, not 2, is 0. So 2 divided by 2, that's 1. So we'll just say x squared. And that's why we want to do it. If it's a 1, 1's a perfect square. Plus 5 over 2, x, negative 2 divided by 2 is negative 1. Now, this is a perfect square. This is as well, but the polynomial itself is not a perfect square trinomial. It's not a perfect square quadratic function. So we still do need to follow the same kind of rule there. We're going to add 1, x squared plus 5 halves x, leave our blank here, equals 1. Now we need to figure out what goes in that space. So we'll do 5 halves. We need half of that. So 5 fourths. And then we square that. So 25. So we'll just use that line there. 25 twentieths. Got to add that over here as well. We'll change the 1 to 20 over 20, make that 45 over 20. And go ahead and get rid of this to clean it up a little. And we'll move the rest of the function down. X squared plus 5 halves x plus 25 twentieths. And so now this is a perfect square trinomial that we can use to our benefit in solving this equation. So here's our polynomial. Now this might seem like it might be a little difficult to factor out. However, we already know the perfect square of 25 over 20ths. We squared something to get that. I erased it on this other page already, but we did 5 fourths squared earlier to get that 25 over 20. So we already know what square that square root is. So this is just x plus 5 fourths squared equals 45 over 20. Now, we'll begin to solve this one. This one's going to be a little complex, so we may not simplify this all the way down to an irrational number, but we'll at least get to solutions maybe in radical form. So we'll square root on both sides. X plus 5 fourths equals plus or minus the square root of 45 over 20 minus 5 fourths minus 5 fourths. So this is our solution. Now this may be able to be simplified a little further in radical form. You certainly could get the decimal answer for this as well. You could do the square root of 45 over 20 plus or minus that, and then subtract 5 fourths from that. But to save time for the purpose of this video, we're just going to leave it there. The big idea, what I need you to understand here is this page, how to get from a non-perfect square to the perfect square. Now, we did just complete a couple lessons on imaginary numbers, so I want to show you an example of a quadratic function where understanding imaginary numbers and the fundamental rule of algebra, the fundamental theorem where we have to have two solutions, where that's really applicable. So we're going to go ahead and complete the square on this one. I'm going to go through this a little faster because I want to get to the imaginary numbers. So x squared plus 4x equals negative 12. So 4 divided by 2 is 2. 2 squared is 4. So we'll say plus 4. So this is x plus 2 squared equals negative 12. Maybe you already see where this is going. Square root, x plus 2 equals the square root of negative 12. So what we see here in this example is kind of that issue. Before we talked about imaginary numbers, we would have had to have said that there is no solution to this problem, and that's kind of true. There's no real number solution. However, there are two solutions to this according to the fundamental theorem of algebra. So we're going to go ahead and continue to solve this. Minus 2, minus 2. So we have plus or minus the square root of negative 12 minus 2. So let's use what we know about imaginary numbers to continue to simplify this. So again, we've got plus or minus the square root of negative 12 minus 2. Now, square root of negative 12 is not a real number, but we can say plus or minus I times the square root of negative 12, because the square root of negative 12 can be thought of as the square root of 12 times negative 1. And we know the square root of negative 1 is I. So let's simplify this out using what we know about imaginary numbers. Plus or minus I times the square root of 12 minus 2. Now, the square root of 12 is about 3.46, so plus or minus 3.46 I minus 2. Now, what we talked about before, these are not like terms. This will give us two different complex numbers that we could write in the form a plus bi. So our solutions here would be negative 2 plus 3.46 I and negative 2 minus 3.46 I. Now, these solutions are complex. However, they are solutions, and there are two of them, which makes sense because this function is quadratic, as a degree of 2. Therefore, there must be two solutions, and there they are.